Hello and welcome to my new video. This time I will speak about how to generate fractals using L-systems. Fractals are structures with repetitive motifs, and particularly present on different spatial scales. Script-based modeling is very much suited for generating these structures. In this video I will speak about one specific approach for constructing fractals, so-called Lindenmayer L-systems. I already produced a video about fractal branching showing a more intuitive approach, and there also will be more videos on other types of fractals, but today we will work on L-systems. In L-systems, fractals are created from simple geometric forms by repetitively applying certain replacement rules. In our first example, we start with a simple 2D square and we replace straight lines by the element indicated here. After a first replacement, we end up with the following structure. You can try to do further replacements by yourself on a piece of paper or on a chalkboard. With my vector graphic programs, it is becoming too tedious. However, there's also another formal approach of doing such replacements, which I will show you now. All we need are the following conventions. F means go ahead, minus means turn right, and plus means turn left. Then the original square can be encoded as f minus f minus f minus f. And our first replacement rule as f is replaced by f minus f plus f plus ff minus f minus f plus f. When we apply this replacement rule using a program like Perl me 20 years ago or Python U nowadays, we will obtain a more or less complicated string depending on the numbers of replacement cycles. Here I'm giving you the string obtained after 2 replacements. And here is the corresponding geometric structure. It was created by translating the string just produced into a Porphrase script based on various cylinders, again using some supporting program like Perl or Python. You will find all necessary scripts and programs in my GitHub account with the address given, as always, in the comment section to this video, so don't hesitate to try yourself. Of course, this is only the beginning, and if you take a look at Wikipedia, you can create many nice natural shapes using L-systems. I will restrict myself here to a few more formal examples. Let's shortly go through them. I've collected all scripts and supporting programs in my GitHub account. We start with a relatively simple replacement rule, which is applied 4 times. The starter is a simple line. In the next example, we start with a square again. The replacement rule is applied 4 times. Here again, a square is used for starting, and we apply the replacement rule 4 times. And in my final example, we start again with a square. The replacement rule is applied 5 times here. I hope this video together with the video on fractal branching has convinced you that script-based modeling actually is the way to go when it is about fractals. In my next video, I will introduce a few more examples on fractals, which I thought might be interesting to render. See you then.